All right, let's get started. So 4 minutes, we were just fine-tuning the slides to give you the best content. And I'm Reinurm, so I was invited here to talk about something about Kubernetes, and I thought about, let's talk about security. So security it's very wide topic, and I'm mostly gonna touch with areas that I have personally toyed, and some things which I consider very important audience should know, and I don't have like my personal experience. I still brought it out, and hopefully one day I have more skills. So I have used Docker since 2015, when it was considered a hipster technology. And what I mean is that back then Docker containers were meant for development or testing only. And if you go to production, you are insane. So I went to production with Docker back then. And another myth was that, all right, it's fine. Go to production, but only for stateless applications. And now I can hear all about it, how stateful applications are containerized and they're running in Kubernetes cluster. So when I started with my Docker and container journey, my motivation was just to create development sandboxes for the developers in centrally deployed server. And at the beginning, I used the infrastructure as a slide. I had very awesome Ansible scripts, but it took like 15 to 20 minutes to go through all those automated steps. And when I was developing, testing, and it was so much pain that, okay, I had to wait like 7-8 minutes, and now it's an error. So I had to figure out how to make shortcuts, what to test out if my automated step actually works in Ansible. So when I thought, is there any better way to generate, back then for me it was like 20 development environments, so it was a relatively small company from a development perspective, but I still wanted to optimize my work. So and I discovered that there are different kinds of isolation mechanisms, like lexical containers, and I actually started with like a Lexi container before that Docker, and I only moved to Docker because that Ansible had a support for the Docker. With Lexi the containers, to bootstrap the instance, you had to do some manual steps, and scripting was a bit too hard. Maybe I wasn't skilled enough, but anyway, with Ansible and Docker we worked very, very, very well. So, but back when orchestrators started to emerge, so 2015 Kubernetes was released as an alpha version, and I was, why not? Let's give it a try. I was using Google Cloud anyway, and Kubernetes was accessible as we were. So all those alpha and beta features were released, and Kubernetes wasn't so popular. Just in case, we released virtual machines where you can just deploy workloads using Kubernetes manifest. So that we had a kubelet running, and you just into metadata you added the manifest, and it deployed your process or application as a container. But back when it was alpha, a lot of things were changed. Where every time the new release was, were many breaking changes, and and back when Kubernetes wasn't documented at all. I had to go to IRC channel to ask, well, what did you break? Why didn't you document it at all? But it will break when I deploy it. So I got trauma and I moved to some other toys. So anyone has heard about Tutum or Docker Cloud? So, because Docker was such a hype, everybody were building their own orchestrators, and Tutum was one cool tool that allowed you to orchestrate AWS resources and deploy containers on top of it, kind of like the Terraform with web application. Anyone knows about Terraform? Yes, all right. So Docker incorporate bought it and rebranded as a Docker Cloud. And same time, we were building their own orchestrator called Docker Swarm. So, which was back then, it was a very cool concept. You had, if you know how to use Docker engine, and we created the abstraction layer in front of it, multiple Docker nodes. And the API was exactly the same as a single Docker engine. So you didn't have to learn anything new. And because I knew Docker engine, how it works quite well, when Docker Swarm was kind of natural for me. Of course, it had a lot of issues, but Kubernetes had ideas and concepts from how Google runs their own infrastructure. And so as Kubernetes still got more traction, when Docker look, we have so cool features like for example, that the cluster guarantees that whatever happens with nodes, that workloads will recover. With Docker Swarm, it wasn't kind of possible. If your application was deployed as Docker container and your node goes offline, when it didn't automatically heal, you had to go and help it out. And if the Docker Swarm node came back, and you had like kind of strange state that if you had 2 instances, when suddenly you had 3 instead, and Docker Swarm back then didn't track the count of it, like how many instances your deployment should have. So we created the second iteration and we called it Swarm mode, and silently dropped it. So of course, I looked at Swarm mode as a new fancy features, and I moved over there. So I managed to stick, I think, 2 years with Swarm mode. It was kind of nice for the stateless services, but some very simple things like Kubernetes jobs or Kubernetes cron jobs, that if you wanted to have something like that, when only solution was that you deployed as a service and you had a cron inside. Which for some reason, if I haven't mentioned that I'm working in Pipedrive, well, for our developers, they liked it really well, that they just need to know only one concept, that they have to deploy services, and they can work around it if they need some job style workloads. So I think like 2020, Docker Incorporate sold well enterprise business, and we were back when we were looking that okay, we have so many issues with Docker stack that every time we want to do something like a deployment tool, we have to build our own. There wasn't any ecosystem back then compared to Kubernetes. So all the innovation, all the cool tools, they were Kubernetes first. And we saw that all other orchestrations like Mesosphere, Ranchers, Rocket had own Chorus had their own tooling. They all dropped that. They declared that Kubernetes is the way to go. So eventually, swarm mode it's Docker states that it's not dead, but I don't say it's live either. It's kind of in zombie mode. But the project is maintained, but no new development is happening. Only alternative, if you don't believe into Kubernetes, is HashiCorp Nomad, which is actively developed. But fun fact, HashiCorp has a very lot of cool tools. They still kind of support Kubernetes as well, and in most cases, like Kubernetes support is kind of must-have, and Nomad is kind of like if there is enough resources left. So first question: who can tell me what is container? And and this is what I came up with. I went to the Docker site and I copy pasted from the first page where container definition. I asked ChatGPT, what is container? I got the same first sentence, so it must be true. Anyone tries to have different opinion?
Thing that goes on the ship.
All right, ship. Any other ideas? So if you want to secure Kubernetes, you need to understand what are you securing if you don't know what are containers. All right. So I'm teasing with to test it out. Are you awake? So now you are afraid. But at any random point of time, I can ask you some embarrassing question. So I stole a picture from Jesse Brazel's slideshow. If you want to know more about it, where it's from, there is a link to a YouTube presentation. So anyone can explain what is namespace?
Tool for isolation.
Tool for isolation. Very nice. Now you are talking in container terms. So can you bring some example? What are we isolating inside container?
Dependencies.
What?
Dependencies.
Dependencies. Can you be more exact? How do you isolate dependencies?
Well, if my SQL container and that my SQL context is installed in the binary itself.
So, all right, now I'm gonna retranslate what you wanted to tell me. You wanted to tell me that that there is a namespace called mount, which allows to isolate file system between different containers. Very nice. I like your answer. Maybe I'm not totally correct, but so definitely the first answer that it's the tool for isolation. So there are if we compare with virtual machines, can you tell me what's the virtual machine in essence is? So it's a hardware layer abstraction. So that's what I wanted to hear. So you can, if you ever create a virtual machine in cloud or in your I don't know, virtual box, you have to like define how many CPUs, do you want to have a disk, do you want to have a floppy disk? Anyone have toyed with floppy disk? I'm pretty sure Lauri has in some point of time. So or how much memory you want. And when you create this virtual box the definition of a machine, and then you can deploy or install the operating system on top of it, or some kind of software which is able to interact with hardware directly. But with containers, at least if we talk about so Linux containers or Windows containers, we mean that we expect operating system is already present, and the operating system takes care of hardware for us. Our aim is to isolate our application, and how we isolate is that we isolate process IDs. So if you, who has done exec into container in Kubernetes or Docker? So have you run ps aux or something, htop or top command? How many processes have you seen? It's not many. It's usually, depending on your application, it's either you see two processes. It's one which is usually running default in container. I don't know, your MySQL process, and then another command and another process is the command which you query how many processes you have. Is it the PS or something? If you have, if for some reason you have decided that you have multiple processes running in single container in Kubernetes, it's a bit of against the pattern that you should have one process per container, and in pod you can run multiple containers, which is do some namespace sharing, but let's don't trust. Then so you isolate the container process with process IDs. So there is some translation happening, mapping, because if you go to the host level, you still see the MySQL and all the other processes on the node. So also file system isolation, so that if you go to a temp folder and you store something, then in other containers you don't see it unless you share those temp folder via volumes or some other ways. And there are many more namespaces. Definitely important namespace is networking. So if you have localhost running, it means that you are running in your own isolated networking namespace. So what is C groups?
Security feature.
Maybe. I wouldn't say it's a really security feature, but you can always translate anything into security.
For accounting.
Accounting what?
CPU cycles.
Exactly. Yes. So this is how we use, how we manage resources for the containers. So either how much CPU time they get, or how many memory is allocated, guaranteed, or limited, or even the block devices. So what happens if you set the C group for like memory like 10 megabytes and you try to allocate more? Like 11, you're exactly, Lauri says like this, so it means the operating system will send the home killer to read that process that hey, you got you are only allowed to have the 10 megabytes. But what happens that if you set the CPU like, I don't know, 0.1 some random unit and you try to use some more? Will it be killed again? No, it won't be killed. So what will happen then?
You break, you hit the brakes.
Yes, the operating system throttles you. It's like you, hey you stop here, everyone else go through, and now you can go and do your cycle. If for some reason your application tries to take more. So in essence, that if you want to create like Linux and maybe Windows container as well. Can't talk much about Windows world, but in Linux world, namespaces and C groups is minimum to create isolated process. But now comes a question to security, how those are handled. And even before that, Docker containers were operating systems had many security features available. So who has played with SLinux or AppArmor? So Lauri has played both.
I wish I didn't.
So lucky you, Lauri has played with SLinux and AppArmor. He doesn't have a life. So definitely why I'm bringing those out is that those are SLinux is kind of Red Hat SUSE Linux is used in Red Hat SUSE Linux and AppArmor in Ubuntu world. I'm not sure if Debian has also adopted that. But in essence, you can configure in kernel what kind of access processes can have. So you can lock down that some sensitive part, like in proc folders, processes can't go and write something nasty. And back then, Docker container, we kind of plugged it into so that we created their own default profiles, which restricts what kind of sensitive operating features have been denied. So who has heard about capabilities before Docker containers? Yes, one gentleman has heard about it. Would you like to tell something about it? Any example?
Some tools need elevated access, then you have to find proper capability which gives it.
All right. Does it in case of Kubernetes and Docker containers, or in general outside as well?
I have experience from the Docker side.
Yes. And the reason is that also Docker engine and Docker engineers were quite serious about this security, that additionally for user requirements there must be non-functional requirements filled in as well. So capabilities whitelist was added. For example, one capability which is very important is that can you have access to a networking at all? If that is removed from the white list, then these containers should be able to work without networking, and it would be more secure then, I guess. So then another interesting feature, and no new privs, that wasn't no new privileges. This means that the container can't fork the process. I read about it. That was actually implemented for Kubernetes first. And I'm not sure if a Docker engine even has it. But Docker engine is kind of, in Kubernetes world, is kind of dead anyway, so doesn't matter. And finally, second profile. Who has heard about what are second profiles? So Lauri, something.
It rings a bell, but I don't remember the details.
All right. So I don't know if Jesse Frazell definitely made a long blog post about it. But so second profile is a syscall filter. Which kind of creates eBPF program, and it monitors what kind of syscalls can be executed. So if by default you want to, if you start the reboot command inside container, it won't reboot your host because it has been filtered out. And again, Long time ago, it was only available for our Docker engine only, because Kubernetes kind of, we were afraid that this is some Docker madness, can have a lot of breaking issues. But luckily, I think a year ago, we started to adopt this piece of security feature as well. So in essence, like if you compare it, if you need to know how to protect it, when those are the features. If you want to go and fine-tune it and lock it even more down, you have all the tools available. Is it Docker or Kubernetes? They are all present. And I think, and there are even more things. And one thing that with security perspective that I dedicate extra slide is the privileged access rights. So just remember all the cool security feature here, and you set on the privilege flag true, all gone. Now my question is that you pretty much have all the access to the node. There are some use cases where it makes sense, like if it's like some kind of node agent, like security agent scanner, some networking agent or kube system kind of requires full control over the node. But if you deploy your own application, maybe web application exposed to the internet, why will you ever sacrifice all the security features if you turn it on? Maybe you build the honeypot, maybe it makes sense, but be aware that if you turn on the privilege, or if you see that the privilege is turned on, that you should question, is it justified? Another thing that I have discovered, and especially, so what's the competition for security people where they defend the infrastructure? Like every year, there is one big event. It's like one locked shield, yes. So I had a opportunity to go to Lockshield, and I was kind of taking care about the Dockerized workloads. And I asked the security company to provide their software and see how it actually works. And it turned out that only thing that we discovered or it was useful was that if some new rogue containers were deployed. Other than that, if the application had the code injection vulnerability, sorry, most security tools don't discover those. I'm also in Pipedrive. We have been doing proof of concept with several security vendors and deployed like remote web shell applications, and unless you do something very obvious, you like start the nmap or some mask scan, when they report that this is can be malicious and it's an anomaly. But other than that, they don't block it unless you use some known script like Python, the Python command, and those which are well known, they are able to block it and report it. But other than that, if you have like some OWASP vulnerabilities, so you have to fix your application first. If you don't do it, you have lost half the battle. So, but few things, what can we do? and also I'm still sticking with basics, and I will go to Kubernetes, I promise. But as everything starts with container, you need to know how is the Docker image is built. So stating the obvious, well, all images should be built with Docker files. I don't know if anybody even knows, but actually you can make the Docker image out of running container. Has anyone tried that? You just create the container, you do your manual steps, and then you do a snapshot out of it. Like very convenient if you don't know like how this Docker file event should look like. What do you even know? That you do all this everything manually, and then you create its event called Docker commit, and you export it, and you even can export it as a tar file. So you also need to know what kind of what are your dependencies. So base image, and the fact is that it's not about the question when the vulnerability is found. It's when, and the smallest the base image, the less smallest footprint. But some new nasty vulnerabilities are found. So I brought down that maybe distroless is kind of good candidate, especially for Golang or let's say for applications which are compiled and stored as binaries. When distroless image usually contains some CA certificates. One etc past file with 2 users for root and non-root, and some time zoning. That's like the kind of basic what every application should need. Other than that, only the slimmest thing is the scratch, that it's you start totally empty if you don't need those certificates, but when you need to manage those root user differently. So know your base image. I have been using Alpine quite a lot, but with Alpine you need to be aware that we use Muscle C compiler, and some workloads it doesn't work well, especially with Java. With Node.js I haven't seen any issues, but recently I read some ranting that with Alpine images, Node.js application and DNS discovery works only over UDP. TCP is not supported. If a TCP is mandatory, then yes, you need to switch it something else. In my experience, we have managed to stick with the UDP packet for DNS resolves. User. Anyone knows what the user tag means in Dockerfile?
Don't do it. Don't do it.
Don't do it.
Actually, in one of the prior workshops, we did a bunch of these examples, and actually, my point of view was that rather build the image as root and use the security context on the runtime to drop the image.
If it's so yes, if it's your conscious decision that keep it root and handle it outside, then yes. Why I'm bringing it out is like 90% of cases why some breaches happen is that application inside containers has root privileges, even though it has the namespaces. So the root user is still like using like a user namespace, and it's a root inside the container. But sometimes there are bugs that you can escape the container. So setting it as a non-root user inside Dockerfile, or using some manifest to set it would be preferred. I recommend to use some multi-stage build, but if you are building your application that development dependencies, like for Node.js or some other applications, we are only used to build the application, and when only the minimal artifacts are copied over to the last point. And if you want to go extra slim, there is there is a tool called Slim Toolkit, which kind of analyzes what kind of files, binaries are used, and takes away anything else. But the issue is that you have to run the application and make sure that all the features are kind of covered. So it also generates some syscall configuration. I haven't tried out myself, but I like the idea that you can even narrow it down more. So I mentioned that you need to that vulnerability happen all the time. So if you want to know what kind of vulnerabilities you have, then I really recommend open source project called Rivi, which actually we actively developed, and there are even more. It's not only, it started as a vulnerability scanner, but now it does the open source license scanning, the infrastructure code as assessment. So there is very active development ongoing. And last thing is that if you build your images, be aware what is put into a copy. Usually, if you copy everything into your image, then maybe there are some hidden files. Maybe these hidden files have some tokens. Maybe there are some SSH keys. And from my experience, Pipedrive paid out like the highest like bug bounties because we wanted to be cool open source company. We had some GraphQL Federation service, and we also provided our own official Docker image. And that Docker image had GitHub token inside from our build tool, which had access to every GitHub repo, private repo in our organization. So we were generous that this issue was reported, and luckily we only did that mistake twice. But if you want to do the business, go and crawl open Docker images. Maybe you find some secrets, and if they have bug bounty available, it should be easy money. And the fun fact that we paid money twice to the same hacker for well, different images, but the same hacker. So let's talk about the runtimes as well. So I mentioned before that the Docker engine is dead in Kubernetes world, but it doesn't mean that Docker engine itself is dead. It has some different use cases, but Kubernetes decided that instead of using Docker engine, let's use containerd. And fun fact, even Docker engine uses containerd as the backend. So it's the lightweight runtime to orchestrate containers on the node level, not the cluster level, but the node level. And Cryo is the alternative if you are a Red Hat fanboy. So Red Hat is a very interesting company that they developed all the tools that Docker did, but they advertised it that they are more secure. The difference was that, and I understand their philosophy that in Linux you should have one tool which do one thing one thing only and do it well. And they had like to build the Docker images. They developed the tool Builder to run like single containers. They had the Podman, instead, like Docker engine had everything compiled into one service called Docker engine, and you had the Docker CLI as an interface to build the images, to create the containers, and many more use cases. So, well, back to the topic. So, like, if you are considering, there are definitely many more container runtimes, but those should be the most popular. The container is if you deploy Kubernetes scratch, it's usually the preferred default. And most cloud providers deploy container by default as well. But so I will go back to this slide. So containerd and CRI-O, we all create the isolated processes using those Linux security features. So what are those other? gvisor, Kata container, Firecracker. Has anyone used those? Heard about it? Firecracker. So what have you done with Firecracker? Nothing, but you have heard about it. Nice. All right, very nice. You know internals that Firecracker is written in Rust. Rust is also very interesting language, which one day I want to learn more about it. But anything else?
You're going to put the virtual machine inside the virtual machine, right?
Kind of, yes, nested virtualization. But so the idea is that those three technologies created something in the middle that you don't deploy gvisor like on top of the hardware like VMware ESXi, but it's very light. All those three are some lightweight containers which are very fast to boot and should just support very specific application. Like I think Firecracker was mentioned by AWS Lambda. I'm not sure if they actually use it, but there was a reference to that. And gvisor was from Google. They also, for some reason, they started to advertise that gvisor is more secure than a regular Docker container back then. But the real issue was that in Kubernetes, those container security features, they were not as developed compared to like Docker engine itself. So nowadays so Kubernetes is kind of like very modular. You can switch those runtimes, run it parallel. So you can decide that if you trust that Google opinion that gvisor with their own syscall remapping is more secure, but you need to understand that there is like performance penalty because of it. If you can accept it, then go ahead. Or maybe you have another approach that I'm gonna manage my own seccomp profiles, make sure that my application has like more is running in more restricted environment. It's also an approach to go. And I added the last one, WebAssembly. Anyone has heard about that? Some. So can you describe more about it? I can't either, but I have understood that WebAssembly was kind of like alternative runtime for JavaScript in the web browsers, and like in general, what is executed in web browsers, some enthusiasts will bring it back to the server side. So and I remember Docker former CTO Solomon Hykes said that if a WebAssembly would have been present like 2013, 12 when they started with their Docker journey, when there wouldn't have been need to develop the Docker engine at all. So WebAssembly is kind of you build your application and you define their isolation requirements together with your application as well. And some engineers have decided that let's put those workloads into Kubernetes as well. Will it be the future? I don't know, but I think the main reason why Docker containers become so popular is that they made interface so easy enough that you can put any application and into image, and it was quite easy to spawn. So with WebAssembly, it's still quite a unique use case. So Lauri will be quiet. What do you see here? Fork bomb, exactly. Can you tell me about the fork bomb? What does it mean? All right. Yes?
It's a process that starts itself, and then the sub-process will start itself again, and so it goes until the machine crashes down.
Yes, exactly. So if you execute that command in your terminal, then it starts reproducing processes until all the process IDs have used, and operating system just crashes. And coming back to those to gvisor, the story that Google said that containers are not safe because you can execute the fork bomb. But back then, I remember when I went to security training with Docker, that they said that they have a feature in Docker engine, like already it was. So when I started 2015, 2017, so already like 5-6 years ago, we had a feature very simple, that how many processes you can create inside the container. And I checked that now some releases, Kubernetes 1.20, you can also limit how many processes you can spawn. So that if you tell that your pod can have 10 processes when you execute fork bomb, and that's all. You can get 10, maximum 10 forks or less. Only the issue is that you need to define pod beat limit manually. It's not enabled. There isn't any sane default that like 100 processes per pod should be safety default. Okay, back to Kubernetes. We're getting to the Kubernetes. Kubernetes authentication. So, what is authentication in simple words? Authentication is proving who you are. So in Kubernetes, like by default, if you install vanilla Kubernetes, you can use either certificates if you are willing to manage certificates on your own, or using some tool, or static tokens generate. Whereas some proxies which kind of translate SAML or LDAP, but by default they are not supported by Kubernetes API server itself. And one interesting feature is what I think was like really cool, OpenID Connect, because I have background from identity access management. And I did a lot of work with single sign-on and Kerberos at Swedbank. So when I discovered that feature, I was so wow, and it's there like by default. So if you want to deploy your own Kubernetes and have like 2FA authentication, like using GitHub or Google as an identity provider, it's there. Start using it. Or if you use some like more sophisticated identity provider like Okta, or Microsoft has like Azure AD No, you can connect to it and usually those authentication features they are like commercial bundle only, but here it's already present. Only thing is that it's yes nice to authenticate yourself, but the next step is the authorization, and I will go to the authorization parts as well. But with OpenID Connect, so you need to define this one OID's OpenID Connect groups claim, and let's go here. So how is OpenID Connect in essence work is we create JWT tokens. Who knows what this JWT token is? Can you? Very well, please explain me what it is. It's a JSON Web Token. What does it mean? The answer is here. You see, you have a JSON structure. You have some attributes, something which are like kind of mandatory for OAuth protocol, but eventually it's encoded like this. And if there is a very nice tool, jwt.io, where you can take the token and you can translate and see the content. And what you are missing is that JSON Web Token is signed. Here is the algorithm, how it's signed, and it should also verify that everything is correct and not corrupted. But what I wanted to bring out that for authorization, you need to define the group claim. In my example, I took this token from from the official Kubernetes article, and for some reason you call it user role. All right, it's understandable. Maybe it's easy to read. Everywhere else, that authorization attribute is usually called group, but it doesn't matter what it's called as long as the value is the array. But the thing is that with the OAuth protocol or OpenID protocol, the authorization data, those groups or roles, it's not defined in the standard. And it means that if you connect to Google or GitHub, this data is not present with the free version. Even with the Okta, it's not available easily. There are some workarounds which we did back in Pipedrive when we implemented, and it's all publicly documented in Okta side how to get this data in, let's say, in the cheaper subscription, but the more expensive subscription, it works kind of out of a box. So, and why you need this bit is that to tell to Kubernetes what kind of access rights you are entitled to. If you don't have it, then you need to. There is a maybe workaround is that you map users directly to the role, but if you have hundreds of users, when doing that individually, it can be a bit pain. Maybe you find a way to automate it. That's a option as well. But usually you manage this way that users are assigned to some kind of group, like in Active Directory group. Or Okta group, and when you propagate that or forward that data to Kubernetes as well. That's I wanted to bring it out. So authorization part, it's very interesting that what I read about it from authorization. So we're still advertising two things which I have never seen it. Maybe I'm ignorant, but like attribute-based access control. And as far as I have read it, the role-based access control, RBAC should have replaced it like quite a long time ago, but it's still there. So, and in essence, for me, they look very similar. The node role is, or node authorization is mostly meant for kubelet, the Kubernetes agent only. And there is the webhook, that you can outsource it from authorization. I have never seen that it has been used. All those operators, if you ever deploy some automated tools, they usually define their own RBAC rules. So I can say that the RBAC is de facto standard. So, who has created any roles in Kubernetes? Yes, roles. All right, I'm not gonna teach you how to create it, but it's definitely a bit of mind-blowing. As you can kind of, if Kubernetes is a CRUD application, create, read, update, delete, then all those objects you can define that deployment. Can you create it? Can you read it? Can you edit? Or can you delete it? So that's a kind of like role. So you can define what kind of actions, verbs you can do with Kubernetes or objects. And there are two different kind of roles. It's either namespace isolated only when it's role, or it's cluster-wide. So it means that you can access all the object, even ones which are not namespaced. And the role binding means that you can map the actor, either user or the user group, to a certain role. And again, the same logic that role binding is the namespace restricted, and the cluster is the full cluster wide. But just a concept that you need to know. So, a few things that if you ever start assessing, like what kind of there are default roles, like cluster admin, for example, is defined. It's a cluster role actually, and so you can, if you create the role binding or cluster role binding, then you can see all the objects. So you should ask if you start managing access, right? Should that person see the secrets? If yes, then maybe you should give it some more advanced access, right? Or define your by default the secrets are not visible in like let's say read-only role, which is the default. There are another question is that like as in Kubernetes, if you're using RBAC mode, you can actually turn it off as well. But for my sake, don't do it unless you know exactly what you're going to do. Then all those if you're interacting with Kubernetes, you either need your own account or service account. And even namespaces, if you create the namespace, there are some default service accounts created, and you can create with tokens. So the question is, should that role have access to create tokens? And another like also obvious is that should that role be able to create edit workloads? Should it be able to create pods, deployments, stateful sets? Then the fun question is, so if you give it the access, should that person need the exec? Like when I was a DevOps engineer, I treated like Docker Swarm and Kubernetes kind of like PaaS platform as a service, and I thought that it would be very useful for engineers to go in and start debugging in live environment. And when I moved to the security environment and I read all about like security best practices, that you shouldn't do any changes. And if you go to live region, there should be like segregation of the duties, but not the same person who develops shouldn't go and start debugging in live. But those are best practices. But also, if you have small company and maybe startup, let's say the rules are more flexible. And back then, when I started 7 years ago, we were very flexible. We had to get stuff done. Also, you need to consider that should the role have access to great volumes, because you can create persistence, and for security, let's say malicious people, the persistence is very, very important, so that you can continue to laterally move. And final is great role bindings, but maybe if you don't have access to do some like very sensitive or super admin stuff, but if you have access to create the new role binding and give yourself admin access, like hooray, you're an admin now. Another way for security people very loves audit logs. But those audit logs, if you turn on everything, or if you even take those the default policies what Kubernetes own documentations provides, Google has some default policy, Alibaba has their own policy. They can be quite noisy. So, and now it depends what is your use case. Do you need to store everything? Maybe if you are like finance institution, maybe, or I don't know, in military it is important, and maybe you have enough resources to store it. But in Pipedrives we had a like internal requirement, let's keep 3 months data. And once we started importing Kubernetes audit log to our SIEM, it was terabytes of data, and our infra people said, no, you need to optimize it. Do you really need that stuff? Are you even looking at it? No, we didn't look at the terabytes of the data. So we started to fine tune, like, for example, we take the conscious decision, like service accounts in kube system namespace. We are not storing those the data. We expect that it is handled securely enough. Will it be a mistake? We shall see. But we were more, let's say, more interested what our engineers are doing. So we were tracking all those regular users, and of course service accounts from operators what we did, which came from third parties. We didn't know anything about it. We tracked what those were doing. So we managed to shrink it down like kind of like 80% of data. So it was manageable for us. So I can't tell what is the best policy. So if you need to collect the audit log, when and you have like lots of data, it's you need to be creative. And one interesting fact is that so you have 2 ways how to store it. Either API server stores in the local file system or sends it over the webhooks. In our case, the webhooks didn't survive that amount of data. I don't know why, but for us we discovered that storing like as temporarily on the local file system, so that our agent import it. So if our agent crashed for some reason when it restarted, and it was still able to continue importing audit logs. And you may consider that if you have some agent that either your agent should do the analysis on yourself, there might be the alternative instead of writing your own audit log policy. So runtime security. This has been very let's say the project which I have been investing for quite a lot. Mostly runtime security, you can see quite a lot of commercial tools, and they help commercial tools. If you have money, you can buy the time. But the open source security tools requires like kind of manpower or competence to use those. For example, Falco project. What they do is that they have their own rules written in YAML, which is DevOps language, and they generate eBPF program, which in kernel scans what kind of syscalls are triggered. So they can report that if inside container apt-get was triggered, or yum if you have Red Hat Fedora or something. But again, it's still limited that syscall scanning is expensive. So that they usually scan the most sensitive parts, like etc folders, not all the folders. I'm gonna take water. But from open source world, the Falco project is one good alternative if you can't afford enterprise services. Monitor networking. Well, networking, especially if you're running like very heavy networking workloads with microservices, for example, it can be a challenge. So I don't have good experience. But what you can consider is like service mesh was quite a huge hype, but service mesh comes with performance penalties. So especially with, if for example Istio, you can audit everything in your, but it comes with cost. And again, you need to calculate what's the risk and what's the benefit you get. And you can also look to some networking CNIs, container network interfaces. Some have some monitoring features built in, but again, it comes with the cost. So some example, Calico or Cilium for example. And finally, here's monitor audit logs. So as I mentioned, that Kubernetes has quite a lot of data to audit, but you either should have good SIEM that is able to report the anomalies based on their patterns, or you use some tooling and build your own alerts. So some with Kubernetes network policies, I don't have much experience yet, but one requirement is that CNI has to support it. For example, Calico has this, and a couple of more. Just be aware that with any kind of, so what the network policies do, that all the networking kind of in Kubernetes, it's around building IP tables rules. So the more rules you have, there is bit of, it will impact the networking performance. Same, and it's not only the networking policies, but if you also create create the service objects, same can happen. Alternative is to use IPVS if a kernel uses it. I added the eBPF. Is it the future? I have tested out. Well, definitely has performance benefits, but it's also very kind of complex. Everything happens in kernel. And before with Lauri, we had a conversation. Maybe the future will be that those networking decisions won't be done in kernel or using CPU cycles, but in networking interface hardware level instead. And I know there are already products outside, but mostly they are quite expensive and for like heavy cloud or in private cloud use cases. So you should be aware that if you start creating network policies, that one of the security question is how to like segregate the workloads. If you have like multiple use cases and you want to avoid lateral movement, then maybe first you should start with ingress and egress policies. What you control what is coming in, what is going out, and then the traffic between the namespaces. And if you have mastered those and you know how to organize your workloads between namespaces, then you can go more granular, like this my port A can connect to port B. And just for fun, I remember that there is very cool online editor that if you don't know how to write the Kubernetes manifest, then there is point and click and fill the forms, and you can create the manifest here. So I just created that in outside cluster access is accepted, but everything else like in between namespaces and in cluster is default deny. Very stupid policy, or maybe very genius. Let's continue. So who has used Kubernetes secrets? So some gentlemen have used. So do you recommend to use Kubernetes secrets?
It depends.
It's a perfect answer for any answer in IT. Okay, so what has been the hype or the big problem with Kubernetes secrets in general? Plain text, base 64 encoded to be precise. So where was it plain text?
The secret record.
Yes, the secret record, but
if it's mounted to container, you can just console it.
yes, but usually the applications were because the container is universal, let's say, orchestrator for any kind of application, and they don't make assumption that that if they make the opinion that they gonna use the encrypted string, but every application is able to decrypt and use it. That's insane. So, but it's not the main issue. The thing that it's plain text inside container, well, it's justified, and we can mitigate the problem, or let's say the risk, by controlling their access rights. So that if you don't have exec access rights, you can't go into the container and see what is happening. Of course, if you have a vulnerability in your application, you can see the secrets, but when you can see, even in most of like configuration files are kind of plain text, so you can only use like encrypted secrets if your application kind of supports it. So, but the answer what I'm looking is the first bullet point was that it was also stored in plain text or base 64 decoded in etcd cluster, And if the admin or anyone had access to HCD or let's say some backup files, they were easily findable. And now there is a solution that Kubernetes supports encrypting the data. So you can encrypt some certain objects in HCD or everything. I'm not sure, but definitely you can encrypt the secrets inside. And as long as you control those rules, who can manipulate, read it, create it. Let's say that it's the decent alternative. It's all built in. And if you know, in Kubernetes you have like config map and secrets, then those are actually identical. You can use exactly the same thing, but only difference what is you have to define who has access to config map and secrets. And usually config maps are readable by anyone who has been granted to go to Kubernetes, and the secrets are, let's say, is more sensitive and managed differently. What I wanted to also mention about this that service accounts that I mentioned before, like if you create the namespaces, well, usually there is some kind of default service account, and for some reason Kubernetes engineer thought that it would be very cool by default to deploy to inject some random token which has some kind of access to Kubernetes API. Maybe none, but back when the decision was made. Again, this is some kind of interesting example where the use case was that if you need to build a workload to access the Kubernetes API, then it's very convenient you have a token deployed by default. But most workloads aren't with that specific use case to have a need to access a Kubernetes API. So that you need to manually opt out that if you deploy your own web application, that you need to disable service account token mounting. And if you have extra time and you are very security conscious, then one cool tool to manage secrets is HashiCorp Vault, which is becoming kind of de facto standard. Quite a lot of tools have integrations built in. So HashiCorp Vault is open source solution. It's, let's say, encrypted key value system with automated, let's say, lockouts. That in case, let's say, if a node restarts and you need to it starts up in locked mode because it might be maybe it has been corrupted. So but anyway, well, some security conscious decision for HashiCorp Vault has been done to keep your secrets safe. And what's some interesting use cases is that where primary function is like time-limited access tokens. That if you deploy the application which connects to, which gets secrets from Vault, it must something or your application must be able to like refresh the access tokens, so that if it's restarted or if that access token leaks, then usually in 1 hour or in 1 day, depending configuration, this access token is expired. And another cool feature is that they provide dynamic secrets. That, for example, in Pipedrive we use it that if an engineer needs to have access to my MySQL database, we have like self-service portal where we request time-limited credentials for MySQL. So the Vault actually provisions credentials. Well, there are some templates, what kind of access rights. So in our case, it's read-only. There is a process around it, and you have access. And in Kubernetes case, you can have some, let's say, sidecar container which automatically is able to inject the secret based on your YAML manifest, what you define, which secret you want to add. Another cool concept which I haven't played myself, but we should be all aware about it, is that Kubernetes is very, if you have access to the deployment workloads, deployments, Kubernetes is kind of dumb. Whatever you tell that let's deploy the Docker image with the latest tag, although the best practice says that you shouldn't do it because latest tag can change at any given time. When Kubernetes has the features that you can evaluate the manifest that does it follows your policies. That if your policy says that don't use the latest tag, use some very specific, maybe hash instead, you can control it and either change it or block it. And there are many other use cases. For example, I mentioned before, let me go back. Privilege, that was the word. So if you try to use privilege container when using admission controller, you can deny that and reject that deployment. And quite well, almost three are different, and there are many more. Both security standard is quite simple. Both security admission controller, I checked, they have like three like default roles, like privileged, baseline, and restricted. So, and it means that so in privileged mode you drop all the security features. In baseline you have some default seccomp and app seccomp and capabilities, and in restricted it's even more turned on. And open policy agent, it's actually very old thing. It's I think I'm not sure if it's was started together during the Kubernetes era, but they also support different use cases like managing policies on virtual machines or even your application. And Kyverno is policy engine for Kubernetes itself. So, but how do you know if your cluster is secure? I have told you like 1 hour quite a lot of things, and should you go and check my Lauri's recording or my slides, or Google Kubernetes best practices? Actually, there are quite a lot of tools, and then it's not even complete list. So, vulnerability scanner, for example, Trivi has the feature. There are different, like Aquasec is the company who is maintaining those Kubepens and Kube Hunter, which are like the sole purpose is to identify and report non-best practices. Even those international organizations like CIS and NIST have their now best practices, and there are tools in place which has like a GIS reporter. Even commercial tools, we use it as a benchmarks. And Kubernetes has provide own checklist as well. So if you are maintaining your Kubernetes cluster or testing something, or you want to learn about it, then try out and use some of those tools. It will definitely, like if you deploy some default application, like by default root user privileges were not dropped. And as Lauri mentioned before, that you can configure to have like lower IDs. So, and that was all. So thank you for Enterprise Estonia, Credex, Startup Estonia for having this opportunity to have this series, and that was all from my side. Any questions, comments? Thumbs up, thank you. More thumbs up.
Everything's clear now, right?
Now we will be super secure. Now it stops.
So definitely I will share those slides. So the links are there if you want to follow the resources.
Have you ordered some external audit in Pipedrive?
Have we ordered external audit in Pipedrive? So in security perspective, yes, the Pipedrive is ISO 27001 and SOC 2 Type 2 certified. So we have external auditing in place. So it covers all the security, not only the Kubernetes part. And additionally, like if we are using some Google services, and if you are ever going to use some services require to have annual pen testing. So we have, and plus we have a HackerOne bug bounty. So if you discover some interesting bugs, like some secrets in our public Docker images, then please report it, and we will be generous. Hopefully. So yes, we take security very seriously in Pipedrive.
Everyone says it.